In this video, we're going to look at our Jovian planets, our gaseous planets that are Jupiter, Saturn, Uranus, and Neptune. Our fifth planet from the Sun is Jupiter. And Jupiter is known as the Lord of the Heavens because it is the largest planet in our solar system. If we could take every other planet, every satellite, every asteroid, and combine it together, Jupiter is still 2.5 times bigger than everything else combined. But because it's farther from the sun, it's going to take longer for it to orbit the sun. And it only makes one rotation around the sun every 12 Earth years. So we make an orbit around the sun here on Earth every 365 days. But it takes Jupiter 12 Earth years. I don't even want to do the math on that, but it's a long, long time. But because it's orbiting the sun so slowly, that's going to lead to it having really rapid rotation. It's going to spin on its axis really fast. So a single day on Jupiter would last 10 hours, whereas it's 24 hours here on Earth. But some of the unique things about Jupiter, other than the fact that it is absolutely ginormous, is the fact that it has this multicolored surface. And it has these bands that align kind of like latitudinal bands that we see here on Earth. So we can see these bands of like orangish and then bluish material that are aligned parallel to the equator. And most of these different colored bands are all due to its really rapid rotation. Because this planet is spinning so fast on its axis, it's going to create a lot of really strong wind that's going to create these different colored bands. But another really cool feature of Jupiter is its great red spot. But Jupiter is also really cool because it has dozens of moons. We know of at least 67 different moons that orbit around Jupiter. And most of these we've given really funny names to around Greek mythology. But some of the largest moons that are around, and some of the most famous moons around Jupiter, are Callisto, Europa, Ganymede, and Io. So when we look at these different moons around Jupiter, Io is one of my favorites because Io has active plate tectonics. And with active plate tectonics, there's volcanism and earthquakes going on, just like on our planet. So in these images, you can actually see a volcano erupting off of a moon in Jupiter, hundreds of millions of miles away. And in some satellite images, we can actually see lava that's erupted from the surface. I don't know about y'all, but I think this is super awesome. Our sixth planet from the sun is Saturn, which is called the elegant planet because it's just gorgeous. But because we're getting farther and farther from the sun, an orbit around the sun is going to take even longer. Now, a year on Saturn is going to actually take 29 years for this planet to orbit the sun. And like Jupiter, we see that Saturn has a very thin atmosphere. It's made up of very similar gases, and it also has a layered internal structure. But probably the coolest and most obvious thing about Saturn is that it has this really complex ring system around it. And remember Galileo and his telescope, he was the first one to notice that there are rings around some of these outermost planets. So when we are looking at Saturn, it does indeed have an atmosphere, but it's a thin atmosphere that's very different from ours. The atmosphere of Saturn is made up almost entirely of the lightest element, hydrogen, with just a tiny bit helium. So it doesn't have our heavier elements like oxygen, carbon, or nitrogen. So when we look at the clouds that make up this atmosphere on Saturn, they don't have a whole lot of water. It doesn't rain water on Saturn. Because the clouds are made out of kind of toxic gases like ammonia, hydrogen sulfide, we see that when it rains there, it would very quickly kill us if we could survive Saturn's conditions. It would be tons of acidic rain. But just like Jupiter has that great red spot, we see ginormous cyclone storms like hurricanes on Saturn as well. But if we point thermometers at Saturn's surface, we see that it releases twice as much heat as it receives from the sun. So because it's giving off more heat than it receives, it has to have some kind of internal heat source, similar to Earth's radioactive internal core. When it comes to Saturn's rings, they're mostly made up of really small particles that are being held in an orbiting pattern by Saturn's gravity. And we'll see that most of these particles are going to be ice, but there will also be some rocky debris that forms these rings as well. And with the rocky debris, it's thought to be just material that's been weathered and ejected from nearby moons. We don't entirely know exactly for sure where all of this material is coming from, but again, we know that it's either water, ice, or small bits of rocks. So we can separate it into two categories based on its density. Rocks will always be denser than ice. The final two planets in our solar system are Uranus and Neptune, and these two are called twins because they're so similar to each other. With Uranus, this is the one that's slightly closer to the sun, but because we're getting farther away, it's taking longer for each of these planets to orbit. So now it takes 84 Earth years for Uranus to make one orbit around the sun. But probably the most unique thing about this planet, other than its name, is the fact that it rotates on its side. Every other planet in our solar system would rotate like if we just stood up and spun around in a circle. But Uranus doesn't rotate this way. Instead, it rotates on its side. So it'd be like us doing a whole lot of back handsprings over and over and flipping or rotating that way. And while it's not super famous for it, Uranus has rings just like Saturn does, as well as multiple large moons. But the last planet in our solar system is called Neptune, and this is a really windy planet. With this, as it's the farthest planet from the sun, it also has the longest orbit, and it takes 165 Earth years to make one orbit around the sun. But one of the most unique things about Neptune is that it has a really dynamic atmosphere. The atmosphere is constantly moving from one area to another through wind. And out of all of the other planets, this is probably the windiest planet in our solar system. And because the atmosphere is moving around and is so dynamic, we see large storms developing as well. And in this image, we can see the great dark spot on Neptune that's similar to the great red spot. But above this, we can even see clouds forming on Neptune as well. If you remember those really high elevation, kind of ribbony, wispy cirrus clouds, we can find those along the surface of Neptune as well.